Hi, everyone. How are you? Hi, Jason. Juwon. I hope you're doing well. We're going to work on Unit 9 today, and then we'll touch on the projects. I was working throughout the break most of the time. I had to put my dog down 2 Sundays ago. He had cancer, so it took me a couple of days to get over that. Yeah, so I wrote a machine learning course, and I'm finishing up big data course for data science. I also wrapped up some cloud computing courses, and I need to finalize some of the IoT one, and I submitted for associate degree for cybersecurity. So yeah, it's been productive. But did you have a good spring break? Did you do anything fun? I hope you had some relaxing time with friends and family. So I had posted an announcement for skill sets online if you wanted to check that out, and then we'll talk about that. Okay. Let me open up my files for tonight, and then we'll get ready. So check out Canvas, please, and download your assignment and lecture notes. Let me make sure that it's the right file. Okay. And so we're going to go over induction today and recurrence this week. Hi, everyone. If you just joined us, I hope you had a good spring break. Welcome back. We'll wait a minute before we get started. So our objective for today, we'll go over the lecture, the assignments, and we'll talk about the project. That's going to be coming up in about 5-6 weeks. So we have to get ready. It went by so fast. Okay, so download notes and assignments. And let me get into my course. So for this class, I'm caught up with grading, except for the homework that was to be due yesterday. So if you haven't had time to complete the homework, make sure you do that. If there were some assignments in the past that you wanted to submit still, right? Make sure if it's locked, make sure you notify me. So to start, we are going to go ahead and real quick touch on the announcement that I post. Let me minimize the people here. So I had added an announcement today, just a few minutes before we start. With Perkins funding, I was able to purchase skillsetsonline.com. They specialize in certification preparation materials in all different area of computing. So it would be a really good resource for you, especially for your career in different areas. And they have a vast amount of materials. So if you click on the link that's provided, it will take you here and you can go to the menus of title. So you can see the type of certification materials that you would want to prepare for. And in the field, I just want you to know that certification does give you leverage in a lot of areas, in programming, in IT, in system administration, you name it, right? In management. So, the beginning stuff, you would see VMware, it's a hot product. Many data center, almost all data center and cloud environment uses virtual machines. And it depends on different products, but VMware has um, great stuff for certification. I was trained on vSphere, so vSphere is highly demanded, especially for IT, management, networking, security, etc. So if you go down, this section is on EC Council, and they specialize in cybersecurity certifications like ethical hacking. Um, so there are different training tools there. And then for auditing, for management and security, you would see ISACA here. And if you do the boot camp for these, they normally run from a few $100s to thousands of dollars. So it would be a really good resource for you to kind of dip into and see what kind of skills that you can expand. And then ISC certification is really highly demanded in security and IT as well, from cloud to data to HIPAA to different areas. And it's one of the top demanded, as I said, certification. So a lot of stuff in security, but you will also see courses from Microsoft, okay? Like Microsoft administration, with Windows environment, server environment, and so on. Okay, some of the old stuff. I think a lot of companies are still using Server 2016, um, and some have upgraded to 2019. However, you would see some of the legacy stuff and then Windows 10. So you can check out the title, and with the library card that you're going to get when you get the access, you have access to one or many courses. Okay, so if you wanted to go into Azure development, you can pursue fundamentals and actually acquire Certiport for this type of certification. So I had posted that in the past as well. Okay, so you can check out a lot of the tools. And then for development, you can look at software development fundamental for Microsoft, C#, if you have skills in C#, that's really for Microsoft application development. And then you can get into other areas like XML, HTML, JavaScript, you name it. So there are tons of stuff that you can use. And what will happen is when you look at the announcement, let's go back here. If you click this is the form that I created because I have to send them a list of access. So if you fill out the information, and they require that you have your name, your email, and your phone number, because most companies use multiple ways to authenticate, especially with your text. So that's why you're required to put in your phone number. And then because of the license, we are going to use the RCCD email. Okay, and you don't have to be an MVC student. You can be a Norco student, RCC students. This is open for you. So if you want free access for the year, make sure that you sign up. And then what I'll do is I will send them a list of the people who needs access, and then they will notify you once they activate your account, and that will take a few days. So you can find the information in our announcement for today. It's under free certification prep materials. Okay. All right. Any question with this? Okay, so let's take a look at what we have to do this week. And welcome back from spring break. I hope that you had fun, had some good relaxing time. I haven't had a chance to update your extra credit stuff if you had sent in, but I will make sure that I will do that. It just, sorry, I got a little bit busy with some things. Okay. And so in this week, we are going to go over mathematical induction and recurrence. You can find the notes. The assignments are here. We are going to do a Fibonacci lab where we will work with recursion and iteration for Fibonacci. You have an extra credit quiz game that's going to expire on the 25th. I don't extend these extra credits as I offer many options in extra credit. So if you attempt that, if you get the top score, you will likely win a gift card. If you just want extra credit, you can just submit your score and you will get extra credit. That will help you prepare for your quiz, which is also due at the end of the week. And that's going to cover chapter 8 through 11. So as we left off last week, we are in chapter 12 and 13 this week. So make sure that you complete the quiz by the end of the week. And also if you want the extra credit, make sure you do that before you take the quiz. That will help you. Okay, and then also look at your assignment, your homework assignment that I assigned previously before the spring break. Okay, and then later on at the end of the session, hopefully I will reserve some time to talk about our course project. Okay. All right. So let's touch on your notes. So in the notes and also in the textbook, it starts with defining mathematical induction is a way to prove statements and natural numbers. And it's used in many different circumstances. For computer science, we care about this is because we want to be able to see how this would be applied in our algorithm, in the way that we design our systems and our applications. So what we want is we want to produce inductive reasoning, which is a method that would allow you to supply some evidence for truth based on what's given as a base case. Okay. So the example that's shown here is in the past, we talked about how we would plug in a certain n value and be able to start with building out our sequence. And so this is going to continue that process, but we wanted to really look at how we would be able to prove a certain type of statement, right, based on some given details in our problem. So the induction, it includes two steps. The first step is to establish a base case, okay, which is usually given, and that's used to prove the given statement for the first natural number. So that's the first thing that you have to do is to establish a base case, okay? And the second step is to prove the given statement for any natural number that's implied in the given statement. So that could be the next natural number or the subsequent natural number. And make sure that we know about the induction step for the final and the future quiz. We will have one more quiz after this quiz. So in in the principle of mathematical inductions, we know that we have to first establish the base case. Then we would follow it up with the inductive step, okay, for the subsequent values. So then based on that, we would be able to build or establish the evidence. So that way we can prove that that is true, right, for most cases, but then could be false for other cases. So then recall that these are your set annotation symbols, okay? So I included there here to kind of give you a list of symbols so you can read this statement and be able to know what it means. Then on page 2, it talks about the example and how to be able to start with the equation to prove that if that equation is true. So in this first example for section 12.2, it says that if we take P with the set of values n for which the equation is true, then we'll have shown that the equation is true for all n. And that's your goal, is to show that the equation would be applied and it would be true for all n value, not just one value, but all the n values. Okay, so then what we want to do is we want to start with some kind of base case. And we wanted to establish the inductive process following that. So let's look at the example, and it says that prove that every amount of postage of 12 cents or more can be formed with using 4 cents and 5 cent stamp. I know that many of you don't use stamp anymore because we have email and we have other ways of communication, but people still send out postal letters to pay their bills, to communicate with their friends and family, etc. So we know that we have to prove that every amount of postage of 12 cents or more can include, right, 4 cents and 5 cent stamps. So we want to establish combinatorics, right, combinations of 4 and 5 cents to make it equal to 12. Okay, so first what we want to Sorry, I got dropped off of Zoom for a second there. It's a little spotty right now, as my husband's also teaching online. Okay, so as we were talking about that, we wanted to prove that every amount of postage 12 cents or more can be formed with using 4 and 5 cent stamps. So our P of n is going to be postage of n cents can be formed using 4 cents and 5 cent stamps. Then on the next line, we wanted to state our claim. So what you want to do is first, you want to provide or restate, right, the requirement for your proof, which is P of n or F of n. Then in the next stage, what you want to do is you want to put down your claim. And in this case, we're claiming that for n is greater or equal to 12 cents or more, P of n is true, and that's what we're trying to prove, okay? And in this case, we are doing a strong induction proof for n, okay? So what do we know about the base case? With the base case, we would start with we would say that for n is equal to 12, because it has to start at the base, right? N is greater than equal to 12. So we would start with 12, and then we would move forward to 15, 13, 14, and then 15. Okay, so we would start with 12. Okay, so our base case would be n is equal to 12. So our next part is to be able to plug this in, right, to see if that's true. So we can say that we can form 12 cents from using 3 of the 4-cent stamps. So if you have 4 cents each, right, you would have 3 of those to make it equal to 12. Okay, so that's one. Then next, we're going to look at 13. We can form postage of 13 cents using 2 of the 4-cent stamps, which gives you 8 cents, and 1 of the 5-cent stamp, which gives you 13 cents. 13 cents. So that's also true. Then for C, we say that we can form postage of 14 cents by using 1 4-cent stamp, right? And 2 5-cent stamps. So that adds up to be 14 cents. So that's great. Okay, that's also true. Then next, we would look at 15 cents. So we can form postage of 15 cents by using 3 of the 5-cent stamps. Okay, and so on. So as you can see in this, what we wanted to do was we wanted to plug in the base case values as we provide the inductive steps, okay, to show that P of n is true. Okay, so in our conclusion for this problem, we would say that P of n is true for all statements of the base, which is 12 cents, 13 cents, 14 cents, and 15 cents. Okay, and that's what the problem asks for. Okay, now take that into the aspect of other type of programs. Okay, we would look at some of the other programs, but let's take a look at our assignments for now, since we started talking about induction. So in the first question, it asks you to define mathematic induction principle. And it simply is a technique used to prove specific statements about the natural number very directly, and it can be applied in a wide variety of circumstances. And you can find this on the notes. Mathematic induction is a way of proving a mathematical statement by saying if the first case is true, then the other cases are true also. Okay? Any question with the one? All right. So we can find this definition in our textbook or in our notes, or if you search it online, you can also find definition there. So let's work on our proof for number 2 using induction principle. So we're given the statement 2 to the n power is less than factorial of n for n is greater and equal to 4. Okay, so in this statement alone, we already got our P of n, right? We got our base case. So we would start with the step. First step is to state your base case. So in number 2, our base case is gonna be n is 4, okay, because that's given to you here. Okay, so as we have the base case as n equal to 4, we would plug in the 4 into the n, As you can see that I wrote that here to see if that's true. So if I take 2, right, to raise it to the power of n, which is 4, that gives me 16. And if I compare that to factorial of 4, so 4 times 3 times 2 times 1, right? So you can take your calculator if you're not sure. You can use scientific mode, okay? And then you can find the factorial of n. So 4 factorial, that gives you 24. So 24, right, is equal to 24, okay? So if we take 2 and raise it to the power of 4, which gives you 16, and 16 is less than 24. So that's true, right? Because this is equal to 16 and this is equal to 24. So 16 is less than 24. So that's true. Then we would then begin with our induction step. Okay. So we would say that n can be equal to k if we wanted to apply the formula, or you can just use n, that's fine. We would say let k is greater and equal to 4, because our base is at 4 and we show that it's true. Then the next part is going to be inductive step for subsequent value, which is k plus 1, right, which is 5. Okay, so we can say that if we assume that p of k is true, that is 2 to the k is less than k factorial, this is our induction hypothesis, then we can prove that p of k plus 1 is also true, given that 2 to the k plus 1 power is less than k plus 1. So if we're looking at 4, right, we show that that's true for our statement. Then if we look at the next value, which is a plus 1, that will be 5, right? So if we plug 2 to the 5th power and we compare that, we plug 5 in for n, we would say 2 to the 5th power, is it less than 5 factorial, right? If it's also true, then we can also show true for 6, 7, 8, and 9 for the n value. So the mechanism of this is really, as you enter the induction step, right, the proper way is to state your induction hypothesis. Then you would want to state what you want to prove based on what was in the base. Okay, so we can say that all the subsequent value k plus 1, that would be true, assuming that p of k is true. Okay, so then what we would have is we would first look at the induction hypothesis. Okay, 2 to the k power or 2 to the n power is less than k factorial. And we showed that earlier, right? 2 to the 4 is less than 4 factorial. 2 times 2 times 2 times 2 gives us what? 16. 4 times 3 times 2 times 1 gives us 24. So that's true. Okay. So now in the next step, what we want to do is we want to take this, right? And algebraically, when you apply something to one side, you have to balance it with another side. And there are many ways to approach your inductive step, right? You can utilize a certain mathematical law in order to really apply that. So in this one, what I did was I take 2, and which is the n plus 1, I would multiply it by, or to the k plus 1, I would multiply it by 2 to the k, right? Because if you take 2 to the k times 2, it really represents 2 to the k plus 1 power, okay? So this allows us to represent k plus 1 by doing 2 times 2 to the k power, okay, on the left side. As I do that on the left, I have to multiply 2 on the right side, okay? So then what I would need to do is I would take the factorial of k and I multiply it by 2 to compare and see if this is, the output of that is going to be greater than the 2 to the k plus 1 exponent. So as we multiply everything out, we would have 32 is less than 48, which shows us that it's also true, okay, based on our hypothesis when we go into induction. Any question with this so far? Okay. Oops, sorry. I meant to kind of adjust it so you can see everything there. Okay. Then, so that's the next step, right? And then the following step, what we want to do is we want to show that k plus 1 is larger than 2. Okay, so we would take 2 times k factorial, which was from here, okay? And we wanted to show that in the subsequent value in the factorial, it is greater than the previous factorial. That's what we're doing, okay? Because this is gonna lead us into factorial law, okay? So if you have the factorial of k, if we multiply it by 2 based on the last one to represent the k plus 1 exponent, so we brought that from here down here, we wanted to show that it is less than the next factorial value, which is k plus 1 factorial. Okay. So here at this point, if you plug in your base number, which is 4, to test, we would have 2 times 4 factorial, right? That gives you what, 48. And then we would do 4 plus 1. 4 came from our base number, plus 1 give you 5, and 5 factorial, right, which is greater than 48. So if you check your calculator, if you take 5 factorial, that gives you 120, and 120 is definitely larger than 48. So that's also true. So in inductive step, what we want to do is we want to be able to take the statement, right, and interpret it and be able to apply the base value so that way, and mathematical law to be able to show that subsequently it would be true for the natural number following the base. Then in the next step, we would look at your k plus 1 factorial, which is the number, because if you're looking at 5 times 4 times 3 times 1, right? And then the next number is going to be 5 plus 1, which is 6. And you would take 6 times the factorial value. So this really represents the following factorial output or result using our inductive reasoning. Okay, so after 5, we know that it's going to go to 6, which is 5 plus 1. And we would take, if we want to represent 6 factorial, we would say 6 times 5 factorial, right? Which is going to be the value for the following. So what we want to do is we wanted to check if this is going to be equal to 5 plus 1 in the parentheses with the factorial. Okay. So we would have 4 plus 1. We've used 4 because that's from our base, right? 4 plus 1, which gives you 5, times 4 factorial, okay? And we said that that's 120, and 5 factorial is also 120, which gives you true. And this is true, and how we apply this is by the definition of factorial rule, okay? So based on these steps, we can conclude that our proof is shown that our claim is true. So depending on the math classes, right? In some math classes, most math classes, they want you to state all your inductive steps to show, right, that your claim is true. So here, this is what we would require for exercise number 2. Any question? No question. I have a chat question or a comment. Okay. All right. Okay, good. So then let's try the next one. Okay, let's do number 3. Okay, so number 3 asks you to use induction principle to prove that 3 of n minus 1 is multiple. That means multiple of 2. That means it's even, basically, an even value. When you time 2 to any number, it gives you an even output. For n is greater and equal to 1. Okay. So what we want to represent is we want to prove that 3 to the power of n minus 1 is going to be an even value for any n that is equal or greater than 1. So given the statement, you already, number 1, have your base case. So that's the first thing that you would do, is to state your base case. N is equal to 1. Then since you have your base case, let's plug it in to our equation and check. So 3 to the first, that gives you 3, subtract 1, which gives you 2, right? And so subsequently, we would see that with 2 to the second power, right? That's the n plus 1 or k plus 1 value. That would be 3 to the second power minus 1. So this gives you 9 minus 1, which gives you 8. So we start with the base case, then next we are going into induction step. We would say that let n is equal to k, right? Because it's just a variable, it can hold any value, right? And in our case, for the statement, It can hold value that's equal or greater than 1. So if you let n is equal to k, then we would say that we would let k be greater and equal to 1. And just like number 2, after we convert n to k, we would then make an assumption. We would say that assume that p of k is true, that 3 to the k power minus 1 is going to give you an even number or a number that's multiple of 2. Then we need to prove that p of k plus 1, any subsequent value, is also true. That is 3 to the k plus 1 minus 1 is also going to result in even number or a number that is multiple of 2. So after you state your assumption and your objective in the proof, you would then begin with your hypothesis in your induction step. So we say that 3 to the k minus 1 is by induction hypothesis, right? That's basically from here. We bring that here. And then we plug in for k is 1. We would see that 3 to the first minus 1 is 2, which is true. Then the next step is to plug in k plus 1, right? So for the next step, we would say 3 to the k plus 1 minus 1 is going to be equal to 3 times 3 to the k minus 1. Remember, recall, in the last exercise, we talked about exponent, how we treat the exponent. So when we take 3 times 3 to the k, it really represents 3 to the k plus 1, isn't it? So since we have the base value, at this point, we would plug in k as 1. So we would have 3 raise it to the power of k plus 1, which is 1 plus 1. Then we subtract 1, which gives us 3 times 3 to the first minus 1, which is they are equal. Okay, so 8 is equal to 8, because on the left side, you would have the 8, and on the right side, you would have also an 8. So now what we want to do next is we are going to bring down the 3 to the k plus 1 minus 1, which we established here. Okay. And we wanted to show that the outcome of the product of that would be multiple of 2 for all subsequent terms. Okay. So I would then plug in k is 1 for 3 to the k plus 1 minus 1. And I show that that would be 8 on the left side. And because we want the output to be an even number or a multiple of 2, we want to illustrate that. We have to get to that point, right? Because you can prove all of this. So what you're doing is you transition this to show that your output would be multiple of 2. So what we want to do is we would want to take that and interpret that by saying that we would take 3 to the k minus 1, right? Plus 3 to the first times 2 because it is an even or multiple of 2. So we would have the left side, which we know that it would be A. And the right side, if you multiply this out, this gives you 6 plus 2, that gives you 8 also. So that is also true. Okay. So based on those steps, we can say that thus we prove that our claim is true. Okay, any question? I used to have a math professor that if you miss any proof steps, that's like 75% of your test questions, even if you state everything else. So, and he used 4 tokens per test. So if you miss one question, that you miss a token, basically you don't get any good grade on the test. So, and this was at UCR. But yeah, so the reason why we really want to be very clear about it is the transition in your step. It should provide clear evidence in how you're proving your claim. And that's very important. Okay. So we would go from the given statement and we want to expand on that, right? And then we want to come back to what is asked of us here and to show that all of these would be true for subsequent values. Any question with number 3? I know the exercises are a little lengthy and it requires a lot of typing or writing, right? But I want to make sure that you learn how to do it right. Okay. All right. So now let's flip back to the notes real quick. So there are a lot of different examples that's illustrated in the notes. And then you can take a look at the explanation about, for using inequality law. And I think the best way to practice is to do the problems. Okay. So if you wanted to do more induction proof, right, you can, and more, they have more complex problem that you can work on. And I'm sure that they address this in your math classes as well. So this class is really applying mathematical principles to the computer science side. So I want to make sure that you understand the basic before we transition into the programming and how that would be applied. Okay. So these are some 2 exercises that we can use to illustrate very basic and induction principle. All right. So in the next part, we're going to talk about recurrence, which is chapter 13. And many of you have been introduced to this from the programming side long ago, right? When you took CIS7 or other basic programming classes. I cover this in Java. I also cover it in other programming classes because, you know, recurrence is used quite a bit in almost a lot of the applications that we write. So here, what you have is it talks about recurrence and how we would have recursive procedures or recursion or recursive functions. Okay. And from the math side, we would say that recurrence is really an equation or a formula that specify the running time, right? I'm sorry, from the computer science side, which is what we would apply the equation that would specify the runtime of the algorithm on the element of n for the function, and the function of the runtime on the smaller of the elements. So recursive function is a function that calls itself, okay? In the case of Fibonacci that you're going to see in the lab this week, is we use it quite a bit in Fibonacci or those type of sequence, is that in order to derive the subsequent value, we have to do some arithmetic operation with the prior values. And you saw some of this last week, okay? Meaning that for Fibonacci, you would add the two prior numbers to get to the next, and so on. And so that way we can scale out for that sequence. But in the case of merge sort, and we talked about sorting and searching algorithm in the past, you can apply recursive call because it's operating, it's doing the same thing repeatedly, right? Not that it's only looping, but it's utilizing the output from the previous process, the previous task that it runs in order to derive to the next. Okay, so then you would use recursive call for merge sort, and that allows you to isolate the first and the second halves of that container, right? Because what we're doing is we're breaking down that container to halves, right? And then we remerge it back as it sorts. So in order to build it back, it has to pull the output from the previous round. Okay, so that means that it has to build it from the subgroups so that way it would return it from the recursive call. Okay, so here it gives you a little bit of explanation on how that would be used in the development side, right? And it tells you here that if you let T of n that represent the total runtime of the merge sort of the n element, then in the step, we would have to illustrate that T of n divided by 2, which is half, must be the runtime of the merge sort for each of the half of the container, half of the subgroup in that container. And for step 2, in order for the n operations that's required for the merge sort two sorted groups with the total size of n, the total runtime of the merge sort T of n is going to be twice that. Because what's going to happen is it's going to have to execute for each of the half. So we have a half and a half. So the total runtime is going to be 1, which is twice of the half when it sorts it. Okay, so with that, what we see is we would have T of n is going to be 2 times T of n divided by 2, which is ultimately would be T of n and plus n. Okay, so this introduced you to how that would be applied to computer science. And then for solving this, right? If you look at what we would derive from the merge sort, okay, and then if we were taking a look at how it would break down to half and half again and half again until it can't reduce anymore to the single element, and when it merged back, right, So we have to evaluate the runtime based on the expressions. Okay. So here, what we would see after we would write that out, right? And if we apply K in this sense, we would see that when we look at the T of n, it's really, the K would represent your log 2 of n, or natural log 2 divided by natural log of n, okay? Which is what we've seen previously when we looked at the sort algorithm. So going further, it gives you the explanation. Now let's come back to the assignment and we would then next, we would need to define recurrence. So recurrence relation is an equation that expresses each element of the subsequent as a function of the preceding one. This is why we say recursive function call itself. So again, recurrence relation is an equation that expresses each element of the sequence as a function of the preceding one. And we would see that in our Fibonacci lab this week. And last week we talked about arithmetic progression, or not last week, the week before swing break, right? Unit 8. And looking at geometric and quadratic. So you understand how sequence work. And we generate based on specific pattern, right? Specific growth, whether it would be a common ratio or a common constant. So we would then be able to apply recurrence functions or method or subroutine in order to build out our program. So with that, when we look at number 5, sorry for the details here. So it asks you to find the recurrence relation and the initial conditions for 1, 5, 17, 53, 161, and 485. And based on the definition, we know that recurrence relation tells us how we would get from the previous term to the future terms. So we would then, like what we covered in Unit 8, we would look at the difference between the terms, right? To really see the progression from one term to the next. And you don't have to write all of this down, right? The highlight is actually the answer, but I wanted to put down the explanation so you can see clearly. So what I did was to compare each of the term, I put it into a table because I'm a very visual person, so I need to see the difference, right? And you can do subtraction. So if we take 5, subtract 1, we get a 4. 17, subtract 5, we get a 12. 53, subtract 17, we get a 36, and so on. So we look at the difference between the terms from one term to the next. And based on that, we see the progression in the difference, right? And based on that, what we see is there's a common factor. So if we go from 4 to 12 to 36 to 108 and 324, which are the difference value, we would see that we would have a common ratio of 3. So you would take 4 times 3 gives you 12, right? 12 times 3 gives you 36. 36 times 3 gives you 108, and 108 times 3 gives you 324, which are the difference values. So here, what we did was we noticed that there is a growing in the factor of 3. There's progression. Is it in the original sequence? So let's take a look, right? Is there something that would be pattern-based with that common ratio? That's what we're asking. So if we take 1 times 3, we get a 3, right? 5 times 3, we get a 15. 17 times 3, we get a 51, and so on. So if we multiply our sequence, each of the element by 3, what we see is that we would end up with 3, right, 15, and so on. And the output is going to be 2 less than the next term. Okay? So if you look at 1 times 3 is 3, right? 3 is 2 less than 5, which is the next term value. And then when you take 5 times 3, you get a 15. 15 is 2 less than the next value, which is 17, and so on. So based on that, we can come up with our equation. Okay? So 3 is the common ratio, right? And A is your first value in that sequence, and 2 is your distance from 1 to the next. So basically we're stating that A of n is going to be equal to 3 times A of n minus 1. We take the previous value, multiply it by 3, then add it with 2 to give you the next term. So that's how you come up with your answer. Any question with that? So just to recap for number 5, what we did was first, we take a look at the sequence and we have to determine what is common in that progression. Okay? And in this case, we find that the common in the progression is the 3, the common ratio. It's being multiplied into the difference. Okay? Which gives you that. Then we would take that common ratio and we would evaluate it with the values in the sequence given to really see the progression across, right? So if we take the common ratio, multiply it by each of the value, we wanted to measure to see the difference, the distance between that value and the next value, and that gives you the 2. So that's how we identify the 2, is to take that common ratio, multiply it by the previous number, which is what recursion really means, is to use the prior value to derive the next. So you would take that common ratio, multiply it by the previous value, and look at its distance from the next value, and you would be able to get the D here. Okay. And the A comes from our sequence, the 3 comes from the common ratio, and the D we determine last. And so that ties back to arithmetic progression that we cover in Unit 8 before spring break. So to write it out in the equation that would apply recursion, you want to indicate not just the A of n, but how that would be represented with the previous value, which is A of n minus 1. Okay. Any question with number 5? Okay. Okay, so let's look at number 6. So for 6, it tells you to use recurrence relation concept to check that A of n is 2 to the n plus 1, which is the solution to the recurrence relation A of n equal to 2, A of n minus 1, given that A of 1 is 3. Okay, so we have to look at the relationship, okay, across based on recurrence relation. So we wanted to check first this given statement expression, A of n is equal to 2 to the n plus 1. And for the recurrence relation, A of n is equal to 2 times A of n minus 1, starting with our base, which is 3. Okay, I know math classes, they use A of 0 as the base, right? And you would see this in array like element 0, right? For the sake of the exercise, I wanted to treat first element as first element, so that way we're not confused. Okay. So first, what I'm going to do is I'm going to take this equation, which is, it says that it is a solution to this equation. Okay, so first we're going to take the first equation, and we would start with A of n is equal to 2 to the n power plus 1. And we would start with the base value, which is 3. So when you plug in 1 for n, you have 2 to the first plus 1, which is 3, and that checks out here. Okay. That's what we're using this one here. Then next we plug in the n is 2. So A of 2, then 2 to the second power plus 1 gives us 5. A of 3, 2 to the third plus 1 gives you 9. A4 is going to be 2 to the fourth power plus 1 gives you 17. Okay. I can stop there. I can go on if I want, but that's all I need really to look at how that sequence would be. And we wanted to see if there is this sequence is really also the output for this equation, given the recurrence, right? We're building it from the previous value. So then the next step is to take the recurrence relation equation here, and then we would start plugging in the value. We would start with A of 1, right? So if we would say A of 1 is 3, that's what we have, then we would go to A of 2. So if the first value is 3, we wanted to check the subsequent value to make sure that it's the same as what we calculated previously. So then here, what we're doing is we're going to plug in the n minus 1 value, which is 3. Okay. So A of n minus 1 value here, which is 3 for 2. So 2 times 3 minus 1 is equal to 5. So once we have the 5, we can build up the next one. So for the next value, we would take 2 times 5 minus 1 equal to 9. Now, definitely there's a distinction between this one and this one, right? Because the second equation relies on the product, the result from the previous value in order to build out the sequence, right? There's a relationship to the previous number. Okay, where in the first equation, we simply plug in the n, which is the element position, right? The n position in that sequence, okay, to build out all the values, okay? So if you check it, everything matches up, 3, 5, 9, 17, and so on. So we can say that A of n equal to 2 to the power of n plus 1 is the solution to the recurrence relation a of n is equal to 2 times n minus 1 minus 1, starting with a of 1 is 3. Okay, so it is true. Any question with 6? All right, no questions. Okay, so I guess we can move on to 7. We only have a little bit more to go. Okay, and then we'll talk about the project and then we'll wrap up for the night. It's pretty light. Let's see, I just want to double check and make sure. Okay. Sorry, the notes doesn't have as much example problem like what we're doing, but I want to make sure that you see because we're going to come back to relation in the future weeks, you see. Okay, we have to take a look at the relationship between containers and so, and then also in graphs. All right, for number 7, it asks you to solve the recurrence relation a of n is equal to a of n minus 1 plus n, with the initial term is 4. Okay, this one's easy. We don't have to do too much. Okay, so we would then use the given statement here, the function. Then what we want to do is we would start with a of 0 is 4. Then for the next term, a of 1 is going to be 4 plus 1 equal to 5, right? Why is it 4 plus 1? 4 represents a of n minus 1, and 1 is the value for n. So we would have 5. Then we would move into a of 2. And since you already have 5, we can take that 5, bring it here, and then we're going to add the n, which is 2, gives you 7. Then a of 3. Then we have 7 from the previous term. Bring that down, plus n, which is 3, gives you 10, and so on. Then let's take a look at the progression, right, across these terms. So if we take the first subtracted, or I'm sorry, the a of 1 subtract a of 0, you get a 1, right? If I take 5 minus 4, I get a 1. Let me write that out. Okay. And then if I take 7 minus 5, I get a 2, right? And then if I take 10 minus a 7, I have a 3. So as you can see, when you look at the difference, the progression in the difference, just like the other one that we just looked at earlier, number 5. Okay, 1, 2, 3. So you guess it, the next one that will be the difference is going to be 4, and the difference is going to be 5, and so on. But if you look closely, this number represents n. So after we do the subtraction, we find that A of n minus A of n minus 1 is equal to n, right? Because if you take A1 minus A0, you get a 1, 1, A1, right? A2 minus A1, you get a 2, 2 and 2, right? So A of n minus A of n minus 1 is equal to n. So then what we want to do is we would find the sum for both sides. If we add everything up, and this brings back to series, right? Sum of the sequence, that's what we talked about last, right? So if we look at the sum of the difference and the sum of the sequence, what does that represent? Okay. So here it shows you that we add up the sum of the difference. We have 1 plus 2 plus 3 plus 4 plus n. Okay. So then if we take a look at A of n, that will be n times n plus 1 divided by 2. So ultimately, what is really the outcome for this? Okay. What we see is the question asks us the recurrence relation for this. So if you look at the output, the sequence, so first we establish the sequence, then we move into looking at what the difference of the values would be and how that would represent in the end. And so when you have it as sum from both sides, this is going to be the output. This is what you want. So your A of n is going to be equal to A of n minus 1 plus n, given that A of n is equal to n plus n times n plus 1 divided by 2 plus A0. When we test that, we would have A of 1 is equal to 5. So the solution for the recurrence relation in given the initial conditions, A of n is equal to n times n plus 1 divided by 2 plus 4 is going to be, that's going to be the output. So that's the answer. This is the answer. Okay. So how did I get from the difference to what I have now? Well, I have to do sum for both sides. So if you add it, because it's half, right, on one side compared to the other when you divide it by 2. So A of 1 is going to be equal to 4. Okay. A of n times n plus 1. That's coming from here. Divided by 2, that represents half. So this is going to get translated to what we have in the subject condition for the recurrence relation. And if you don't know why this is divided by 2, you remember Gauss trick from week 8? That's what it is. When you do the sum, you take the first and the last, you add it, and then divide it by the 2, right? So what you have is you have the series that is represented in the relation. So coming back to arithmetic sequence and series, that this is where it came from. Okay. Any question? So questions for quiz and tests is going to be multiple choice, but it's going to ask you something like this, right? Select the options that would represent the recurrence relation for this sequence. And you have to know how to calculate it. So the recording will be uploaded about 9-ish. It normally takes an hour for it to get ready once I download it. YouTube takes a little bit longer to convert. But in general, it should be about 9-10 o'clock. I have a recording in place from the prior semesters already, but I will update it with this one. Okay. Question? Okay, so we have time. I told you that I would reserve some time, right? So go back, revisit these questions and redo them if you're not clear, right? I know that in the textbook, there's some practice exercises, so you can also use those at the end of each chapter, I recall. Okay, all right. So any question with the assignment for today? All right, so now, oh, I see a chat. Okay, good. If you have no questions, then we would talk about our project. Let me bring you to project. I posted it on Canvas. It's on the bottom. So let's share screen again. Okay, so if you look at the project module, project for this class, this time I released it about a week or two early. Long ago, I would release it like 4 weeks before it's due, and then I extended it to 6 weeks. Now I move it a little bit earlier because just I know you have other classes and things you got to plan for. So I encourage you to work on it a little bit at a time. Okay, do not wait till the last 2 days or 1 day or a few days last week to work on it because you will not get it completed. Okay. And so I designed it to be in multiple parts so that way you and your group can work on it. Now, group is not mandatory in this class, but in my CIS7 it will be. Okay, so if you take my CIS7, you will see that you will have to be working in group only because assembly is a little different and it takes time to kind of, and I require a little bit more advanced stuff in that class. In this class, just to keep in mind, and I know many of you have taken my classes before, and every survey that I receive back from the project, students tell me that they should have worked with another member or a group. Okay, so keep in mind that people are there to help you and it's really good to work collaboratively. So I encourage you to work in groups. Now, if you choose not to work in group, you still have to sign up for a team, which is project part 1, and you would be your 1-person team. That's fine, okay? Now, you know that the real world, you don't work by yourself on development projects, okay? You have to work with other, whether you like it or not. So it's a really good practice that we do so in our classes, okay? So if you look at the objectives, what am I looking for in your project? I want to see that you apply the concept that we talked about, whether it's probability or combinatorics or, you know, to be able to sets, you know, even with recursions, all the components that we talked about, it has to relay somewhere in your project. Some project would have, you know, many, some project would have, you know, maybe a couple topics that we talked about, but I want you to be able to apply it because it's important to understand how to apply discrete math in your algorithm. Okay, so our task is to plan for a team project. If you work by yourself, will be 1-person team. I need documentations, and in this class, I'm a little bit more lax on documentation compared to my other class. So, and in this, you would need to give me a flowchart pseudocode, right? So if you work with other people, or maybe coordinate, right? You can all work on it together, or one person work on it and then revisit it and talk about it and see what you need to fix. Now, building out pseudocode and flowchart, you know that it grows with your program. So what you want to do is you want to build the base and then start to make adjustment to it. So it doesn't have to be static from the start. Okay. Then I will try to link some videos tutorial for you. I forgot to do that when I edit your project. Anyway, then after that, you need to give me a program in C++. Okay. And most of these projects can be done in a simple way or a complex way. I'm not expecting data structure or anything like that, but if you implement it, it's a plus. It's good. Okay. It shows me that that's your capability. You understand how to solve a problem at more of a complex level. Your programming skills is higher. That's fine. I'm not grading you on that area of programming. I'm grading you on the application of discrete, how you solve the problem with your algorithm. Okay. Then I need you to use the portfolio. The reason why we implement this is I talk to Cal State San Bernardino and UCs all the time, and they tell me that, you know, they do portfolio for their students and it helps their students get work. So maintain, I know that you use GitHub quite a bit, most of you, but having another site for people who are non-tech savvy to look at your stuff is also, recruiters, they are not tech savvy, okay? In the real world, recruiters are gonna be out there to hunt you down and be able to find you. So they are, you know, LinkedIn, you know, Google sites, those are the places that they normally look. And then, you know, if there are technical people, then they'll look on GitHub. Okay. So this is why we should use Google site because it's the easiest. And if you already had one because you had me as a faculty or instructor, you can reuse your site. Just add your project on there. That should be easy. So everybody has to submit their own. Okay. Now, the documentation and the program, you can share that as a group, but you need to submit on your own because, right, with that, you have team rapport, and also it's a lot easier for me to manage your grade without messing up, okay? When I grade stuff in groups, and if there's one person that submit, it creates a bunch of problem in Canvas, and you know, it's just so messy to fix. So I want you to submit your own project, even though you shared the program and the documentation, okay? Then you need to evaluate yourself and or your team. So if you work by yourself, you need to do a self-evaluation. And it is a good way for me to see how you understand what you need to improve on. Okay, all of us do, right? It's a good way to do self-assessment, and you need to do that occasionally on how you will be able to transition forward. And it's also showing me who's not doing what or who's doing a great job, and so they should be rewarded for it. Okay, so make sure that you do the team evaluation. So let's take a look at the project criteria. There are 3 parts in your project. It's broken up into different points, values. Point 1, the part 1 is going to sign up for your team. Like I said, individual can be a single person team or multiple people team, but you need to sign up. And that's going to be due in May. So you have a month to think about your project. Okay. Part 2, you are going to submit the C++ program and the documentation. That will be the most points, 200 points. Okay. And I do give feedback to everyone that submit, right? I would highlight some of the things that I suggest and what you need to improve on from your portfolio to your project and so on. Okay. And then your self-evaluation, I do read that, and your team evaluation. And then I do look at your portfolio. One thing that I want you to know in all my other classes in the last few semesters, they submit their URL, but it's not publicly shared, so I can't see it. And, and then I have to email you and say, hey, can you change the permission? And if you don't check your email because you're done with the final, then I have to give you a 0 grade because I can't see any content. So make sure that you enable public view so people can see it. And so there are instructional video on that. All right, so let's talk about the project itself, okay? So this is a part 2 I included here in the project criteria so that way you can see the overall picture. You will be graded on the ability to use discrete structure concept in C++ and how you document and explain your solutions and how you would organize and work with other people. So there's some weight in team contribution. For the team, if you wanted to work in team, that will be 2 or more members, maximum of 3. I had larger groups before and some people didn't do the work and that's not fair. So 3, I think is a good, one person can work on different parts or you can all work together, okay? So here are some of the cases. So in the next few weeks, we are going to cover graphs. And in this semester, I think I'm going to introduce you to some graphing tools like GraphViz, so that way you can actually program it as a graph. We will do some exercises in our class, how to illustrate that in a non-GUI manner, right? Like what we've been doing with a lot of our input and output, just text. But the first case, this is a travel salesman case, and this talks about solar sales. So a marketing person that starts in Riverside, and this person has to go to Moreno Valley, Paris, Hemet to market the packages, okay? So here is the map, okay? The graph for it. So if this person starts in Riverside, right, we need to determine which route is the shortest, the cheapest, and what will be fitting. And you know that companies do this all the time, okay? So in the data analytics part of this, when I was working on the machine learning course and earlier this week, it touches on this, right? And even in data analytics. So how do they determine which route would be best to deliver your packages to, for Uber, etc. So what would be best for bus, train, plane, etc. So graphs is heavily used, and we will touch on this in our exercise and our lecture, okay? So here's the graph. It's weighted, non-directional. So you can choose whichever way that you wanted to start and set your path. And so if he starts at Riverside, which city would be best to visit and how the route should be. So in this program, what you want to do is you want to determine the variations of the trip, right? For the sales. I need you to determine the shortest path, the cheapest or low cost trips, okay? And I need you to represent that in your C++ programming using matrices and adjacency. We will do a lot of practice on this, okay? So I will show you how you can use adjacencies in C++, matrices, and then how to do weighted graphs in C++, okay? So you need to document it and give me the C++ program as the output. The second case has to do more with probability and combinations. And this is about doctors or training physicians that's going to travel to different country for externship work, etc. So it talks about UCR has 100 graduates, Doctors Without Border program, and they wanted to be able to match up language fluency and their areas of expertise and preferences. Okay. So building a program like this, I recommend using case switch, okay? Or if you have a better approach, you can do that. Okay, I've seen students turn in from, double linked list to something simple as vector array. Okay, so now your program is to match the participants based on the language that they speak, sometimes multiple, and their specialized area. And you can come up with your own countries and your languages. So you need to have at least 5 languages to be implemented, right? For 10 countries match. Why do I say 10 country, right? If you're looking at UK, Canada, and United States, right? We speak English, or even Hong Kong, part of Hong Kong speak English, and then Chinese is spoken in a lot of different countries and so on. So you can and Spanish is spoken in a lot of different countries. So you can come up with your own countries and languages and how you want to match that, okay? At least 5 medical specialization must be implemented for the match. And you can come up with your own. If you're not sure, I put a Wikipedia page here for you to look at, okay? And I want you to determine the probability base for that match. So look at the combinations and be able to calculate the probability, and I need you to show that in your program, okay? Many people just give me a matching program and then they don't give me any probability. Then it'll just be partial points, okay? And you need to you need to show how you have done that, your solution, how you derive that, and show that in your programming. That's case 2. And you only have to pick one, okay? Later on, again, we're also going to talk about encryption and decryption, how to do ciphering. And in this one, it's a Vigenère cipher, which is very easy. It's 2-dimensional shift, okay? We will work on 1-dimensional shift using Caesar, but you will have to implement 2-dimensional shift, which is not too difficult. And I'll explain Vigenère in our lecture down the line. So we want the user to be able to enter plain text, like how are you doing, and it needs to convert that string to a non-readable text, okay? Using alphabet, symbols, numerical, depends on the limitation on how you implement your solution. Some are better than others with it. So you can implement alphabetics, numerical value, and here it talks about Vigenère and how it's used, okay? So it uses row and column with the shift. And what it does is it utilizes a key, and based on that key, it's gonna cross correlate the shifted value, okay? And we will come back to this this is from an earlier chapter, but I choose to keep it until the end so you can implement it in you can learn it for your project, okay? So here it talks about Vigenère. And in this program, what I want you to do is I want you to write a program that encrypts and decrypts the message. It should output both. It should give the user the option to choose whether they want to encrypt or decrypt, and then to show the output, okay? And I want you to test the program and verify the output is accurate, because I do test it to the limit. So there are times that, everything works great, and then 5 tries later, it stopped working or it's giving me something bogus, right? So, and I need you to document your solutions and give me the C++ program, okay? So this one is also a popular one in this class. Case 4 is going to be a blackjack game, but this blackjack game is different than your regular blackjack game. This is a card guessing blackjack game, okay? You against the house and the player against the house, and we wanted to guess the probability of the player winning, okay? So at the beginning, it talks about Blackjack Rules. So that way you need to really think about how you would implement these conditions into your program and so on. Just keep in mind that Blackjack doesn't care about suit. So if you're all hung up about making an array with suit and color, it doesn't care about that. It cares about values, right? In a Blackjack game, it's not like a poker game. Blackjack game just cares about the total number of your cards, that sum, and if that sum is going to be Blackjack, under or over. Okay, so don't worry about the suits, the color, and all of that, because if you get hung up with that, that's just going to take a lot of time. But if you implement the suits and things like that to really display and make it look nice, that's more realistic. That's a plus for me. Okay. So here it talks about how to work with soft hands, right? What would be a soft hand? Some casino would treat soft hands a little bit different. Most would be 17 and up. So you have to have 17 in order to stop hitting, okay, as a sum. Okay, and then double down, splitting pairs, and so on. So these are some of the things to consider for the conditions. And here it shows you on how it's treated with variations of the player hands. And this is kind of a good visual to show you how the combination, to compare the player hand with the dealer hand and the probability in winning before that. Okay. Then, so statistically, I pulled this, right, from the web. So if the casino implements a single deck, the house advantage is 17%. Okay. A double deck, the house advantage is 46%. And so most casino use 4 or more decks. And as you can see, house advantage is much higher. Okay. So for your game, you can just use a single deck. That's fine. 52 cards, no joker. Okay. So what's the outcome of this project? You need to write a C++ program using a single deck cards. And in the program, I want you to show the player advantage probability based on the given hand. So if the user is dealt, let's say, a king and a queen, what's the probability of them beating the dealer based on, so it's a card guessing program, right? So you need to compare that against the dealer and the probability with the rest of the deck. So what's the probability of me winning with the two-faced card if I hit it? What's the probability of me hitting an ace if I already have a two-faced card? So it should show, right, the probability of hitting, the probability of winning against the dealer hands. Okay. So it should show the dealer and the player hand, and that's easy. You just have a C out on that. The winning probability for each player hand. You only need one player. I don't need you to implement more than one, but if you do, that's okay, right? But most of the time, one player is good enough. Before and after card hit, right? I have seen people turn in probability hard-coded. Not okay. Okay. I know that you can solve the problem, but if you look at how you can implement the algorithm, and that elevates your program so much more. Okay. Calculation of probability must be integrated in the program. Okay. And we worked on card probability extensively in our exercises already. All right. So you need to provide documentation and approaches and give me the C++ program. So this is the criteria. For part 1, this is not due until later on. Okay. So this is just a page, but in the part 1, it's going to be the actual assignment. So here it talks about how you would sign up for a team. okay? And I link my Google document to that, so you would be able to see who's on which team, okay, or who needs a team. And then once you sign up, you can decide, or if you already decide and you want other people to join you for that case, you can also put the case number or the project case detail, okay? So now on the bottom, I put down some of the tools that you can use to communicate. I know that you are familiar with Zoom. You can use Zoom for free for 45 minutes per session. You can also use Discord, Microsoft Teams, Slack, and so many other tools, right? So the links are there. If you already have an account, you can just create a channel and add the people. So for project part 1, you need to sign up for a team, whether yourself or with other people, okay? So to sign up, you simply click on this link, right? Add your name, and if it's completed, I give you 20 points. That's freebie, okay? And this needs to be done before the 7th, okay? I also posted a page on GitHub how to. I know many of you are familiar with GitHub, but I get GitHub repo that just have codes, right? So make sure GitHub is not required, but I want you to use GitHub to have your source code there and your program and maintain the version as you change it over time. And it's a good way to keep your project portfolio too. Your GitHub should have a README and how to program and what's on your README. I put a link here, okay? And then if you work with other people, you can manage, right? You can branch and you can see, you can pull requests on what's modified. So you can use GitHub to its maximum capability if you know how. So here there's some link about GitHub. And again, GitHub is not required or graded for this project. Part 2, there are documentations that's required and the criteria we just went over. So in the documentation, let me pull that up. Yes, you will have a final exam. And your final exam will be at the end of the semester, and I will review, and it's similar to the quiz, but just everything. Okay, so final project and final exam. I don't do midterm because I want to see, right, application in your learning outside of just answering test questions. So you do have a test where you answer and you have to turn in your project. Okay, so for the documentation, okay, I kind of lay out on what you should include. So if you download the documentation guide, you would see this. All you have to do is fill out the sections, okay? Put together a document. And so you put down your team name and who's in your team, and then answer the questions. What problems are you trying to solve? So what's your case? What solution have you implemented? Explain how you calculate, right? How you come up with your solution, right? It should be, what are the program objectives? So what's the goal of your program, right? What are you trying to do with your program? How should it be interacted? Okay. What kind of discrete structure, how are discrete structures being implemented in your program, right? What kind of concept did we talk about that you use in your project? What are the limitations in your program, right? So if you're looking at an encryption program, you were able to encrypt, but you could not decrypt, then that will be a limitation, right? So that will be future improvement recommendation. Or if your program, have storage issues or whatever, right? So test your program and tell me the limitations. Now for this class, I allow you to do flowchart or pseudocode. Okay, so you can pick one or the other. And so when I read pseudocode, it better not be like 7 lines, okay? Because that's not okay to turn in. Start program, distribute cards. No, you have to have branches in your pseudocode. All the conditions you applied, you have to put that in. Along with, if you're using flowchart, then you should branch also in flowchart. There are quite a few people in this class that were in my Python class in the winter, and they did a wonderful job on either both or either or. Okay, so make sure, and you can expand your flowchart and your pseudocode as you think about how you solve your program. So you would start with stating the task and the subtask and then expand on it if you write out your pseudocode. Okay. So don't just be simple, be specific so you can see, how you would solve that problem and if you're missing anything, and that's the whole point. And try to do it before you program. I know all my students try to do pseudocode and flowchart after. That defeats the purpose. This is part of planning. So I will evaluate your pseudocode or your flowchart, and that will be 30 points. And here it tells you that you need to go from start to finish, okay, to include decision-making branching. If you choose to use flowchart, make sure you also include decision branching and also standard shapes, okay? Now you can use something like draw.io. You can keep it on the cloud. You can share the link with your friends and your teammates. There are many different tools that you can use that are free. You don't have to use Microsoft Office draw shape. That's too tedious. But if you choose to do that, you can. Okay, but there are a lot of great tools for that, and I'll introduce you to a couple programming ones. Okay. All right. We're almost done. So part 2, what are you turning in? A CPP file. So if you have header files and things that you wrote separately, right? Like for cards or something like that, make sure that you include it. You can zip it and put it all together, or you can attach them separately. I know that there's limitation with Canvas, but it's pretty large, so I think you should be okay. And a document that answer everything that's listed. Okay, so I have a chat question. Yeah, so you can use that. You can use Zia. You can use third-party tools. I'm fine with that. Okay, as long as I can read it and I can see your thought process, then that's great. Okay, everybody needs to submit. Don't forget, do not rely on one person to submit. That way, if that's so, then you will not get grades for your project. Okay, last part is part 3. You would need to do a self-team evaluation. It's a survey, so make sure, be honest, right? And I read it, I see, and I weighed in, team contribution on it. So if the person barely does anything or answer any contact information, then if you give that person, let's say, a 2 out of 10, then that person their grade will be impacted. Okay. But don't also penalize other people because you simply don't like them, and that's not right. So make sure that you do self and team evaluation. It is one form, and once you complete it, attach the screen capture showing that you submitted it, and that's 40 points. Your Google Sites, again, make sure that you enable public permission to view. You don't have to enable edit, just view is fine because it's tied to your Google Drive. If I can't see it, right, I would not be able to give you credit. And how do you test this? Just open up another browser, copy and paste the URL in, okay? Like if you use Edge or, Firefox, open it in another browser and see if it opens. If it opens, then it's enabled. If it's not, if it shows page error, then you need to change your permission, okay? And then there are tutorial videos on how to do that there. I don't need it to be super fancy, right? Has your name. If there's a project tab, use that project tab and then add your projects on there. Take a picture of your code, that's fine too. You can upload documents on there. So Google Sites, it has very simple basic tool. This walks you through on how to set it up, okay? And then how to delete, organize, publish, and share. That's important to look at, okay? And so this will be this is yours forever unless you take it down, okay? I have one, so let me show you. I use it for my training portfolio. Well, it needs to authenticate, but anyway, I will show it to you next time. However, you can use it to maintain your projects and, even papers and research paper, history, projects that you've done aside, you should put it on there. It's just a good way to show what you accomplish. Okay. All right. Any questions? So the part 2 and part 3 is actually not due until the end of the semester. So you still have a lot of time left to think about what you want to do. And if you have any questions, tomorrow I'm not keeping office hours from 11 to 1. So it's going to be like from 1 to 4, something like that. Because I have a committee thing that I need to help with interviewing people. So I will post an announcement in all classes for that. So if you need help or anything like that, I will be available in the afternoon. If not, just send me an email or a message in Canvas, and then, I will let you know if I'm available or not. But it's probably should be like 1 to 4. Type your name into the chat. Have a wonderful evening. Enjoy. See you on Wednesday for lab. Good night. Thank you. Good night.